A new era in space discovery. The James Webb Telescope reveals Proxima B like never before. NASA scientists have just crossed a major milestone in their mission to uncover the deepest secrets of the universe. The James Webb Space Telescope, JWST, humanity's most powerful space observatory, has successfully completed its final deployment sequence, marking a transformative moment in our understanding of the cosmos. And now, it has delivered something truly breathtaking. For the first time in history, scientists have captured an image of Proxima B, not as a faint speck or spectral line, but as a visible world with stunning detail. Orbiting the nearest star to our solar system, Proxima Centauri, Proxima B has long fascinated astronomers. But until now, it remained mostly hidden, its surface and atmosphere shrouded in mystery. With Webb's unmatched imaging power, that has changed. The new image offers an incredibly clear look at the exoplanet. Using its near-infrared camera, NIR-CAM, and mid-infrared instrument, MIRI, the telescope cut through cosmic dust and stellar interference to unveil surface textures, brightness variations, and even hints of atmospheric layers and polar features. While not yet as detailed as the views we have of Earth or Mars, this image marks a massive step forward. It brings alien worlds out of theory and into visual reality. What makes this moment so powerful is what it means for science. For years, Proxima B was studied through indirect clues, like the tiny wobble of its star or the brief dimming of starlight when it crossed in front of it. These techniques hinted at the planet's mass and orbit but left us guessing about its actual appearance, climate, or habitability. Now, thanks to Webb's revolutionary optics and light filtering capabilities, we're seeing real data from the planet itself. It's no longer about guessing, it's about observing. Proxima B sits in its star's habitable zone, the sweet spot where temperatures could allow liquid water to exist. It's a rocky world, about 1.3 times the mass of Earth. Until recently, Proxima Centauri's frequent solar flares and low brightness made detailed observations nearly impossible. But Webb's tools, like its coronagraphs and light-splitting filters, allowed scientists to block the star's glare and isolate the faint, reflected light of the planet. From that light, researchers detected chemical traces in the atmosphere, including carbon dioxide, possible water vapor, and even hints of methane. While this doesn't confirm the existence of life, these chemicals match environments that could potentially support it. Infrared data also suggests surface temperatures within a range that wouldn't rule out Earth-like conditions. The visual data revealed striking variations. Some regions appear brighter, likely ice-covered or desert-like, while darker patches could be oceans or thick clouds. Proxima B even has a reddish glow, reflecting the light of its red dwarf star, giving it a surreal yet oddly familiar look. This isn't just a scientific breakthrough, it's a philosophical one. For centuries, humanity has wondered, are we alone? Now, we're beginning to get real answers. If a planet just 4.2 light-years away shows conditions similar to Earth's, it suggests that habitable environments may be far more common in the galaxy than we imagined. Even more importantly, red dwarf stars like Proxima Centauri make up about 70% of the stars in the Milky Way. If we can study planets around them in this much detail, we now have access to an enormous number of potentially life-supporting worlds. The Proxima B image has already sparked massive interest in the scientific community and public alike. Schools, museums, and science centers are using it to inspire future generations. It's no longer just a data point in a catalog, a technological triumph and the dawn of a new era. The clarity of this image is not just a visual breakthrough, it's a triumph of technology, coordination, and patience. Achieving it required extraordinary precision from the James Webb Space Telescope, JWST, operating in the cold, silent vacuum of space over 1 million miles from Earth. Webb's primary mirror, composed of 18 hexagonal segments, had to align to within nanometers, less than the width of a human hair, to focus starlight correctly. Its instruments had to stay perfectly thermally stable, cooled to cryogenic temperatures to detect the faintest heat signatures from distant worlds. But that was only part of the challenge. Proxima B orbits very close to its parent star, Proxima Centauri, completing a full orbit in just 11.2 Earth days. This rapid motion, combined with the star's frequent bursts of solar activity, meant Webb had to track the planet with extreme precision and time its observations carefully to avoid contamination from stellar flares. Rather than a single snapshot, the image of Proxima B is the result of multiple observation campaigns, each lasting several hours and stretching across weeks of coordinated effort. This extended approach allowed astronomers to collect clean, consistent data, filtering out the noise caused by the star's unpredictable behavior and isolating the delicate signals from the planet itself. A symphony of minds behind the breakthrough. This achievement wasn't the result of any single team or discipline. It was a true interdisciplinary collaboration, combining the efforts of astrophysicists, optical engineers, planetary scientists, chemists, and computer scientists across the globe. They worked together to design, calibrate, and optimize Webb's systems and to translate streams of data into a meaningful image. Crucially, advanced artificial intelligence played a pivotal role. Custom machine learning algorithms were trained to separate planetary light from background noise, enhance spectral resolution, and correct distortions caused by interstellar medium interference. These tools transformed faint, messy infrared data into a high-resolution view that revealed the planet's structure, composition, and even its surface contrast. What we're seeing isn't just light, it's a reconstruction of a reality millions of times dimmer than the human eye can perceive, made possible by cutting-edge data science. Beyond the image, a glimpse into Proxima B's climate and potential. This is far from the end, it's a beginning. Now that we have a visual and chemical snapshot of Proxima B, scientists are turning to simulation and modeling to build a fuller picture of the planet's environment. Teams are constructing three-dimensional climate models, mapping potential weather patterns, temperature cycles, wind currents, and how the planet's atmosphere might circulate heat. They're also examining rotational dynamics. Does the planet spin like Earth, or is it tidally locked, with one face always facing the star and the other in permanent darkness? This has major implications for climate stability and the ability to sustain liquid water. Even more exciting is the search for signs of a magnetic field. If Proxima B generates its own magnetic shield, like Earth does, it could protect any atmosphere or surface life from the intense stellar radiation of its red dwarf sun. Without such protection, charged particles could strip away the atmosphere over time, rendering it barren. Initial models suggest that, due to its Earth-like mass and density, Proxima B might possess a liquid metallic core, the kind of feature that could support a dynamo effect and sustain a magnetic field. If confirmed, this would significantly boost its chances of habitability. A new era of exploration begins. The success of this mission doesn't just inform science, it redefines our next steps. One of the most promising future missions is Breakthrough Starshot, an ambitious project aimed at sending lightweight probes to nearby star systems, including Proxima Centauri, at a fraction of light speed, using high-powered laser propulsion. Until now, such missions were largely theoretical. But with real data, images, atmospheric readings, temperature estimates, we can now design those probes with specific goals and environments in mind. Imagine future spacecraft equipped with cameras and sensors, flying past Proxima B, capturing detailed data, and even sending back footage of mountains, clouds, or oceans. What once belonged to science fiction is now on the edge of feasibility.